Hey physics friends, Mr. Collier here. I have another sample problem for you. This one is about potential energy, and it's the potential energy of an object being dropped from a known height. So we've got a 1 kilogram ball dropped from 1 meter, and we're looking at how much potential energy it has just before dropped, or as it's dropped, and just before it hits the ground. So the first thing I want to write is just the equation for potential energy. So potential energy is equal to mgh. Potential energy can be written as a capital E with a little p, and that's the same thing. We can write it as GPE for gravitational potential, or just PE, or even a U, which I don't use very often, but that is another one. So those are all the same thing. They just mean potential energy due to gravity, and this is the equation mgh. And you'll sometimes see this as well. Change in potential energy equals mass times gravity times change in height, because typically when objects change their potential energy, they're changing height, not mass or gravity. All right, so now let's start solving this equation. So the potential energy of the object is equal to its mass, 1 kilogram, times gravity, 9.8 meters per second squared here on Earth, times the height, 1 meter. So I purposefully picked simple numbers that would be easy for you to calculate. 1 times 1 times 9.8 equals 9.8 joules. So that is the potential energy of the object just before you drop it. Now, as you drop it, and this is going to be a major theme going forward, that potential energy gets less, because as something falls, its height goes down, and its kinetic energy goes up. So potential energy gets transformed into kinetic energy. And we'll very often ask the question, what's going on just before it hits the ground? When we say just before it hits the ground, we basically mean height equals 0 just before it hits the ground. Even though, we're not technically talking about once it's hit the ground, we're talking about when it's so close that it doesn't matter, it's the same thing. And in that case, potential energy equals, again, mass times gravity times height. And the difference here is when we ask the question just before it hits the ground, we're going to put that height is equal to 0. So the potential energy is 0 relative to the ground, because it's at the ground. So anytime you see that, when we're using the ground as a frame of reference, we're saying that it doesn't have any potential energy. All of its potential energy is now kinetic. That's also going to be the fastest it is ever moving, is right before it hits the ground, because all of the potential has turned to kinetic. All right, that's it for this one. Let me know if you have any questions.